Welcome to the Tech Blog Writer Podcast, your guide to future tech trends and innovation in a language you understand. Now, over to your host, Neil Hughes.
Welcome back to the Tech Blog Writer Podcast. Now, as regular listeners will know by now, this podcast is about how technology is transforming multiple industries and solving real-world problems, rather than talk about bendy or foldable screens. Now, although Marc Cuban declared that data is the new gold, too often I'm quite conscious that huge amounts of data can't answer the questions that actually matter, because they deliver billions of isolated facts, but zero intelligence. Now, a company called DataChemist recently appeared on my radar because they're attempting to solve this very real problem. They impose and enforce real-world rules onto data, and by doing so, giving their customers more insight than they've ever had before. DataChemist is actually making complicated simple, and they're transforming messy, inconsistent datasets and transforming them into clean, structured, integrated data, and transforming isolated data points into a model of the world as it really is. And the result? Their customers improve decision making and reduce costs as a result. Now, ladies and gentlemen, that is a story that excites me. So buckle up and hold on tight as I beam your ears all the way to Dublin in Ireland so we can speak with Kevin Feeney, CEO of DataChemist. So a massive warm welcome to the show. Can you tell the listeners a little about who you are and what you do?
My name is Kevin Feeney. I'm a CEO of DataChemist. We're a company, a startup company that spun out of Trinity College at the start of 2018. We build enterprise knowledge graphs. And what that means is we take all an organization's data, which is typically very messy. We integrate it all together into a single connection-oriented model, where all of the data is modeled as entities with relationships between entities, for example, customers and accounts and customers and orders. And we can see all this data integrated together in a great big network. And then this makes it amenable to a huge suite of mathematical graph analytics, where we can find lots and lots of patterns that are hidden in the data that were previously invisible.
Now, when I was researching you guys, I quickly learned that DataChemist builds these enterprise knowledge graphs with powerful logic constraint engines. But can you just tell me a little bit more about exactly what makes it unique and what kind of problems you're solving with DataChemist?
Yes, there's an area of graph databases which is where we belong, and this is a different way of modeling data from the traditional SQL relational databases, where we have basic tables, columns, and rows. This connection-oriented view is becoming it has several very strong use cases in fraud detection, supply chain analysis, in networked risk, in a lot of these areas where it's very important that we don't just look at a single entity, we look at how it's related to lots of other entities. So, for example, in supply chains, we can easily have a node failing, for example, a supplier of a company failing, but at multiple hops distance that has a knock-on effect on the particular company. So any use case like that where we have data that the relationships are very important and we may have to look at multiple hops of relationships. The traditional database technology is just not very good at this. It doesn't do SQL technically doesn't do very good at joins at scale. If we have hundreds of millions of these records, for example, we can't see this. And there's lots of areas, for example, in financial services where companies, where regulators, for example, stock exchanges have these vast streams of data. There are bad actors in that data who are trying to disguise what they're doing, hide behind third parties, hide behind agents. And we can make this very clear, or we can see this very clearly in the data, but we have to be able to understand all the connections of all the actors. So increasingly, this is at the forefront of data technology, being able to create these very large graphs of relationships between entities and analyze these at scale. Now, what makes us different? There's basically two families in this in that world of graph databases. There is what's called property graphs, and then there's RDF semantic web graphs. The second one, semantic web, is very academic. We can make very rich descriptions of what the data is and do logical inference over it. The second type is much more is the property graphs, which are actually much more penetration in industry. Neo4j is the market leader there. They have a more practical focus, and the big difference there is that the relationships can have properties as well as the nodes having properties. It's quite technical, but what makes us different, first of all, is that we combine those two approaches. We have a semantic layer built on top of a property graph, which allows us, and what the capability that gives us is, whereas the property graph people are looking at nodes and edges, we are looking at for meaningful business objects. So we have relationships between people and companies, and we can give our graph all sorts of real world meaning, so that it's much more easier to understand by business users.
A question I've got to ask, of course, is what is the story behind DataChemist? Can you tell me a little bit more about how you emerged from the EU-funded Trinity College in Dublin? I think it was a project over there, wasn't it?
That's right, yeah. The Aligned project. This is where the technology really comes out of. In 2015, we got 4 million from the European Union for a Horizon 2020 research project with Oxford, Wolters Kluwer, a big Dutch-German multinational, and a few other partners. And this money was initially actually for a project called the Global History Databank. And this is a very ambitious project that we're a part of, where we're trying to gather data sets describing every society that's ever existed, and thousands of variables about each of these societies, so that we can look for long-term patterns. One of the pieces of work we're working on there at the moment is looking at resilience to climate change. Because, of course, climate change has happened a lot of times before in the past, and there have been extreme climate events. For example, in 536 AD, there's what's called the Proto-Krakatoa event, when a huge volcano blew up and basically gave us a nuclear winter across a lot of the world for a few years. And so this was like a historical climate catastrophe. But what's interesting is lots of historical societies, many of them collapsed during that phase, but many of them didn't. Many of them actually became stronger. And so we're trying to understand what are the attributes of a society that makes it resilient to climate change by looking at these historical examples, so that we can better mitigate the problems in the future. So we were working, basically back to the narrative DataChemist, we were working on this, and we needed a data management technology that was capable of handling this type of information, which is very large. It's also very complicated and full of uncertainty. So we went out into the market and we tested a whole bunch of things, and there was really nothing there that could deal both with the scale and the complexity of the data. So we went off and built our own. This took us some time, but it was very successful. That data we're currently managing that, and it's available on the web. A really fascinating data set. But we then went and discovered that what we'd built had a huge amount of commercial applications. So Wolters Kluwer, who are another partner on this project, they then came to us. They basically have a Polish subsidiary that is the market leader for commercial intelligence in Poland. And they had these very large databases, hundreds of millions of SQL rows, but they had actually quite similar problems, that they were full of uncertainty and duplicates, and there was lots of bad data in there. And just the scale of it, they couldn't spin up new services. It just was really, really expensive because the testing regimes and so on. So we did a project with them where we extracted all the data, turned it into one of these knowledge graphs, and were able to provide them with a whole suite of these new queries, new analytic capabilities over this very large graph of commercial relationships. It has a record of everybody who's ever been a shareholder of a company in Poland since the fall of the Warsaw Pact, every company, every directorship. And so we could find all these interesting patterns that, for example, conflicts of interest, circular shareholding patterns, all sorts of interesting stuff that was nobody had ever been able to see in the data before. It was sitting right there in the data. It was just that once you got it into the shape where it's all integrated and you could search through connections, you could find all these very interesting patterns. So the success of that project then prompted us to go out and seek venture funding. We got that in the middle of last year. We got 1.2 million from Atlantic Bridge, an Irish VC, plus Enterprise Ireland. And basically since then we've been spinning up our commercial offering. We've had very successful engagements with a whole range of large corporates, both in retail, in manufacturing, and in financial sectors. There's lots of people at the moment who have large amounts of data, and it's pretty messy, and they don't know what to do with it. And so this is, this is a really great time for us to be coming to market, because we're finding lots and lots of companies know they should be doing lots of stuff with their data. They know they're not, and they feel that their competitors coming from the internet, the Amazons of the world, who they know are on top of their data, and they have therefore lots of motivation to spend money on fixing these problems.
And I also learned on the back of your research and a further commercial implementation with a big Dutch-German multinational, you recently published a book called Engineer Agile Big Data Systems. So what kind of feedback have you received on that book? And did your family members get a copy for Christmas? Because pretty heavy read.
It's definitely, my family members did actually get copies for Christmas. I'm not sure they appreciated them, but But we got really good feedback from this book. It's quite a research-focused book. So as you say, it is quite heavy. It's not for everybody. But in the process of building out this tech and through this European project, we had numerous theoretical and modeling challenges in terms of how we can build these systems at scale, how we can make them, and particularly how we can make them flexible. How we can allow people to change their minds, change the way that they model their data, change the types of questions that they want to ask as they go forward, because we never know what we should build until after we've built it, and to try and incorporate those aspects into system design. And this is all predicated on the idea that if we're managing data, we want to have a model of that data, and we want that model of the data to be as descriptive as possible. We want to have a means of talking about the data where we can say, for example, a sole shareholder company should only have one shareholder, and a limited liability company should have a management board. And if we don't see that in the data, then there's something probably wrong with the data. So the real challenge in a lot of big data applications, there's one challenge that is scale and velocity and so on. We know about these, but it's getting the ability to manage the data, to understand what is in this data, and data structures change, data sources change all the time, and the ability to have a modeling technology where you can change this model quickly without having to write a lot of code. Like code to me, I'm a coder. But code is the enemy. We want to eliminate as much code as possible. It's very expensive, error prone, and very difficult to maintain. We want to move as much of that intelligence out of code and into data models. This was a area of IT or of computer science that was really heavily exploited gone into in the 1980s in expert systems, for example, but it kind of died a death with particularly the end of the AI winter, so the emergence of deep learning and these type of techniques, and much less concentration on rich domain machine interpretable logical models which computers can reason over. And we see this coming back. This is there's only so far you can get with machine learning against flat sets of features. If you want to go beyond that, you need to start adding a semantic model, allowing the computers to understand how concepts and entities are linked together, and that's what our type of technology can bring to the party.
So just to get everybody listening on the same page, can you tell me a little bit more about your work on knowledge graphs, and maybe share a few use cases just to allow people listening to visualize how this technology can provide their business with real value?
Certainly. So, for example, in fraud detection, many people carry out frauds by basically hiding behind an agent or third party. So pretending to be somebody that they're not. For example, getting a third party to buy shares in a company that you're barred from owning shares in. And there's lots and lots of regulatory concentration on understanding who the actual originator of a transaction is, who the actual beneficiaries are of a transaction, shall we say. And there's lots and lots of interest in various people in disguising that. So if we take all the data of trades between people and We also overlay that with the relationships between people, like who works for the same company, who's a shareholder of the same company, or we can incorporate all sorts of other information like memberships of clubs. There's lots and lots of freely available data that we can use to build an understanding of the relationships between the actors in any domain. Now, if we can create a knowledge graph that links together all of our actors in, for example, financial services, we can very quickly identify patterns and see who's connected to who's acting on behalf of who's acting in coordination with who, and we can pick out these patterns that indicate collusion, that indicate fraud, and so on. So if I'm a regulator in financial services and I've just got a huge amount of volume of data coming in, with traditional technologies, it's very difficult to even look inside that data. You can't follow multiple pathways between people. It's very difficult to integrate it with third parties. Whereas with our technology, it allows you to take all of that data, build a network of relationships between all of the actors, see how and it becomes very quickly apparent who the patterns of coordination between actors, the patterns of relationships between actors. That for example, if I'm trying to identify Iranian companies who are trying to beat sanctions, for example, they won't they will try all sorts of devious ways. People do around such things. They will do it through third-party companies. They will do it through agencies. But if we have that information about who is actually registered as being connected with these various companies, we can follow the links. We can identify who the originator is of transactions very quickly. That's just one use case in financial data. Another very powerful use case is in supply chain management. You've lots of companies in supply chains who produce outputs for other companies further up the supply chain. And this happens at multiple levels, and there's very complicated, often input-output relationships between these companies in the supply chain. If we just have this data in a traditional tabular format, it's very difficult to follow the links. You can't even visualize it. If we make this as a network, where each of the nodes is a company and the relationships between the nodes, basically supplier relationships, we can first of all, we can visualize how revenue and products flow through the network. We can also do things like simulations of turbulence. We can see what happens if we start taking guys out. We can get a better understanding of their actual risk profile. We can also identify choke points in these networks and potential for optimization. And the type of technology that we have, knowledge graphs, give us the ability to make a lot of these type of complicated relationships manifest. Whereas in traditional data silos, this data is all hidden away in the data, and it's just too difficult and complicated to pick out these pathways. This is a universal problem, as you say. Every data in the real world, when people come to look at the data that sits inside their applications, they're often horrified. They're full of duplicates. They're full of misspellings. People spell their names in different ways. People have different identifiers and so on. So this is really, and people often spend a huge amount of money on data integration projects. Traditionally, these have been very expensive things. So this is a problem that's close to my heart. I started out in machine learning and AI, and what motivates me is, like lots of my colleagues, is the really cool mathematical stuff you can do. But what you end up spending all of your time doing is writing crappy scripts to transform data from one messy format to another. And then you can run these big experiments, and then it might become only apparent 6 months later that there was actually all these problems in the data, and so your results are meaningless. So how we actually do this is this is some of the secret sauce of DataChemist. And the critical thing is we build a model of the data as it should be. So, for example, we might specify rules such as a sole shareholder company should only have a single shareholder. Certain classes of companies, like limited liability companies, should have a managing director, a board of directors, rather. And so we have this data modeling language that allows us to specify very fine-grained controls on what the data should look like. Then we apply a range of AI techniques and machine learning techniques to try, and we point our AIs at the data source. and we try to get it to fit the data to the model. Now, a lot of the times, because there's errors in the data, it can't. Sometimes it can automatically, in certain cases, it can automatically fix the problems. In other cases, it can just identify them for the human operators to fix. So when we applied our this approach to the commercial intelligence data set, which is hundreds of millions of rows of commercial intelligence data, we were able to find like something to the order of about 50,000 like definite errors in that data, just automatically, without, just by the basis of there was no possible way of fitting that data into a model. So, for example, we had sole shareholder companies were registered as having 50 shareholders. We had management boards registered for companies that legally should have had no management boards. All of these type of errors in the data. So finding these type of errors quickly is really critical to productivity, because the later in any type of data project, the later you identify the errors, the more costly it is to fix them. So you really want to have a high barrier to entry into your data system, whereby you catch them at the start, you catch them at input, and therefore you can be very confident that you're doing analytics on the basis of reliable and trustworthy data.
Now, way back on episode 263 of this podcast, I spoke to the guys at Neo4j, who are one of the world's leading graph databases. But can you tell me about how much tech has come along since they launched nearly, I think it was a decade ago now? It seems that tech has really progressed now, hasn't it?
It has, yeah. I mean, a really important thing that's changed. So Neo4j, we're the first guys out the bat with a property graph, and they've done really great work in building a following and building an understanding for the use cases of graph. They have some really impressive deploys. So, for example, they run for some really big European consumer groups. They run their entire personalization, customer understanding, customer analysis platforms, and so they're really pioneers now. But what has really changed is hardware. Actually, we now have the ability to load really, really large knowledge graphs into memory, and this is really critically important, because when we're traversing these graphs, we're sometimes doing the equivalent of, we have one example in one of our demo systems where we do 30 million table joins, or the equivalent of 30 million joins in SQL. Now, that's completely impossible in SQL land. We can only do it because everything is in memory, and not only that, everything is compressed in memory, so it fits as much as possible into cache. And this is the really critical difference, is we now have these hardware configurations where we can do, almost like load the entire world, every person in the world and their relationship to one another, into a graph that's in live memory all at the same time. And that really, because knowledge graph technology, it gets more powerful the more data you overlay, and the bigger your network is, the bigger the network you can load. So this is the number one critically important thing that has happened. We have now these hardware architectures and open source libraries and stuff like that allows us to take advantage of them and do things at a much bigger scale than was ever possible before. Now, the second thing, there's also been lots of academic research into how we might model different domains. There's been lots of academic research into how we can do reasoning better over these type of knowledge graphs. There's also lots of academic research into how we integrate this into machine learning approaches. So definitely the field of the knowledge graph technologies have really moved along, and there's in the last probably 2 years, there's been a huge upsurge in investments. There's Amazon bought their own Neptune DB. Microsoft bought their a knowledge graph company. Neo4j just got 80 million investment. Another startup is one of our competitors. Tiger Graph got a 31 million Series A, I think. And this is all on the back of this technology starting to demonstrate itself at really big scales. So Tiger Graph, I think, basically built a network describing the entire Chinese power network, which is obviously very large and complicated, but they were able to build a meaningful graph describing all of the power generation stations and transformers and so on across the entire network, so that they could give real-time analytics on that. So the technology has got to a stage where we can do those scales, and we can make them work in real time. This has only been very recently possible, and that really opens up tremendous potential for these really, really large and high-profile projects, and providing lots and lots of optimizations on things like national power grids, things like international financial systems, and so on.
And there really seems to be a thirst for real-time personalisation, real-time analytics, and that experience economy that we're building. And data is at the heart of all that. And even, I think it was Marc Cuban said, data is the new oil. So it's fair to say there's a lot of energy in this space right now, isn't there?
There absolutely is. And Silicon Valley has been built on the idea of we measure things, we test hypotheses based upon those. We see how those, we come up with some idea about, well, maybe this will make our metrics better. We test it, we measure, and then, the things that work, we incorporate them and we move on. But not just that feedback loop with data. It's also, we're constantly trying to better segment our audiences, because we know that if we look at an entire human population and try and pull behavioral patterns out of them, they're going to be quite weak, because there's different types of people. The more we can cluster, we can understand who has which of our customers have common traits, the more we can break down their behavior into specific subgroups. And the more specific you get in terms of shared attributes of people, the better you can predict their behaviors. So everything now in the world of consumer is going in this direction, where people are trying to gather data to better understand their customers and to identify cultural subgroups within their customers, and then reanalyze those and see how they behave, and get an ever finer grained understanding of the breakdowns of customers and how they are likely to react to engagement by the company.
So what kind of opportunities are ahead that really excite you?
So the future for us is really full of possibilities. Everything excites us. We have some really exciting projects going on where we are finding, by going in and looking at data, for example, in manufacturers, we can very quickly identify really significant cost savings for them, to the orders of tens of millions, that was just sitting there in the data. And by applying our tech, we didn't even have to do a tremendous amount of complicated analytics. It was just integrating it. The patterns jumped out at us. So for me, the future is exciting because it gives us the potential of having much greater data capabilities available to us, whereby we don't have to do any complicated computer programming to get at the data, that we might be able to just at a whim say, I wonder if the weather in Argentina has an effect on the price of beef in Britain this week, and you can just press a button and you can get that data that you need to do that type of analytics. And to me, that's a really exciting prospect. The ability to set our computers the tasks of organizing, managing, and keeping track of this data and what it means. So analysts and computer programmers and machine learning people can just do the exciting, interesting, fun, analytic stuff to try and understand that data. They're not spending all of their time transforming data from one low-level format to another. So for me, that's the motivation that always has driven me. Computers should be able to. There's no good reason why computers can't be better at organizing data and giving it meaning and so on, and transforming it from one format to another, and being on top of that. Humans shouldn't have to do this stuff. So that's the prospect that excites me about the future, making that a reality.
Well, before I let you go, can I just ask that you remind everyone listening of where they can find you guys online, find out more information about everything that you're doing, and also maybe contact a member of your team if they've got any additional questions?
Great, yes. We are at DataChemist.com. You can find any information about us at info@DataChemist.com. But the best way to learn about us is to go to the website, have a look, hit the contact button, and we'll be absolutely delighted to take any questions or queries from anybody has about our tech or what it might be able to do to help them.
Well, I love what you guys are doing, essentially eliminating code, almost making the technology invisible, and just making it incredibly easy to make sense of that vast amount of data that every business has got and deliver true value, and essentially turn messy, inconsistent data sets into clean, structured and integrated data. So I wish you the best of luck for the future, and a big thank you for coming on today.
Thank you very much, Neil. And so thank you very much for having me as well. It's a really great opportunity. It's very important for us to get the word out there. So thank you so much for having me on.
DataChemist builds enterprise knowledge graphs with powerful logic constraint engines. Yes, it's a complex and heavy subject, but look at where most businesses are now. Like I said at the beginning of the show, data delivers billions of isolated facts, but zero intelligence. So I love how DataChemist is attempting to solve that exact problem, but also taking away those big tech concerns and headaches such as coding, so businesses can just focus on the results. And in a world of political polarisation or binary thinking where everything's good or bad, hot or cold, I think it's so important to highlight that this project emerged from European Union funding at the Trinity College in Dublin. Proof, if you ever needed it, of course, that rather than building walls or isolating your country and going it alone, so much more can be achieved by working together. But I don't want to get all political or go on idealistic rants. That's not what this show's about. But what are your thoughts about all the topics that we've covered today and anything else at all? Remember, I'm the easiest guy in the world to find. You can get me on Instagram, Neil C. Hughes, Twitter, Neil C. Hughes. My email is techblogwriter@outlook.com and website techblogwriter.co.uk. Now, I have my first event of the year coming up in Arizona at the end of the month, and I'm really looking forward to this one. And if anyone in tech is listening and cannot afford those crazy Silicon Valley prices, I urge you to check out the great work that GPEC are doing in Arizona. A better standard of life, cheaper prices, better cost of living, 300 days of sunshine. Man, that certainly sounds appealing to me. I will tell you more about that towards the end of the month. And if you live locally, give me a shout and we can have a cold beer or hot coffee. The choice is yours. I always try and meet clients, guests and listeners wherever I go in the world because I'm a big softie. But it's time for me to go now. So a big thank you for listening. And until next time, don't be a stranger.
Thanks for listening to the Tech Blog Writer Podcast. Until next time, remember, technology is best when it brings people together.